Hola, soy Pablo Lozano.
मेरा नाम दीपा राय है, मैं भारतवर्ष उत्तर प्रदेश की रहने वाली हूँ।
Bonjour, je m'appelle Guillaume.
Soy de Zaragoza. Allí estudié física.
Donc je viens de France et j'ai étudié la physique des plasmas et l'ingénierie en France.
Меня зовут Владимир Гроза, я из Новосибирска.
Bună, sunt Simina.
என் பேர் சவிதா, நான் இந்தியாவிலேருந்து வரேன். நான் என் மாஸ்டர்ஸ் பெல்ஜியமில் முடித்தேன். இப்போ ஸ்டீப் ப்ராஜெக்டில் வேலை செஞ்சுட்ருக்கேன்.
Закончил механико-математический факультет Новосибирского государственного университета.
Am absolvit facultatea de fizică din cadrul Universității Alexandru Ioan Cuza din Iași.
मैंने फिजिक्स और मटेरियल साइंस में मास्टर किया है। मैं स्टिप प्रोजेक्ट में यूनिवर्सिटी ऑफ एर्लांगेन में रिसर्च कर रही हूँ।
Y ahora estoy en la Universidad de Nottingham, Reino Unido.
Și acum lucrez la Universitatea din Birmingham.
Bonjour, je m'appelle Maxime, je suis français.
Мене звати Катерина Баштова. Я з України, з Києва.
În cadrul proiectului STIP și sunt un student la doctorat.
Estudiando el doctorado en modelos matemáticos para water jet machining con una beca Marie Curie.
Ciao, sono Stefano.
Maintenant je travaille à l'université de Nottingham et je travaille pour le projet STIP.
Сейчас я являюсь студентом PhD-программы Marie Curie в университете Ницца, Франция.
Vengo dall'Italia, mi sono laureato presso l'Università degli Studi di Padova in Ingegneria delle Telecomunicazioni.
My name is Keith Thomas. I'm from the United States of America.
Auparavant, j'ai fait un diplôme d'ingénieur en sciences des matériaux.
Я отримала магістратури в теоретичній фізиці та в математичному моделюванні.
Attualmente sono un PhD student all'Università di Birmingham e lavoro nel progetto STIP.
На даний момент я працюю в університеті Ніци в проєкті STIP.
Et maintenant, je travaille au laboratoire fédéral suisse en sciences et technologies des matériaux.
And I work at EMPA, the Swiss Federal Laboratories for Materials Science and Technology.
STEEP is a synergetic training network on energy beam processing, from modelling to industrial applications. It is a Marie Curie initial training network funded by the European Commission under the FP7 programme.
My work within the STIP project refers to investigating the material removal mechanism in laser ablation. Instead of varying the laser beam characteristics, I vary the material properties and then look into the changes in the laser beam footprint in those materials.
I do mathematical models for water jet machining. So basically what we're trying to do is to predict how the surface is going to be eroded when the water jet goes over it by developing stochastic models to know how noisy they are going to be, how they are going to overlap, and how we can make 3D complex features with that.
In general, my research is focused on parameter identification for a model of abrasive water jet milling process, and in particular, we try to obtain the optimal parameters for predicted surface.
I work on modeling of the FIB footprints. So I work on two different materials like silicon and silicon carbide. The main idea is to understand the FIB patterning in homogeneous and heterogeneous material and to know what's the difference and to incorporate that in the modeling to get the final 3D structures.
My topic is about the material removal mechanisms in abrasive water jet machining.
I'm studying laser ablation using simulation to try to understand the deeper physics during this phenomena.
We are looking at the microstructure within the material and how does it affect the material removal mechanism. And to do that, we use a range of characterization techniques which include microscopy, focused ion beam, and so on.
Within the STIP project, I have to study material removal mechanism during focused ion beam processing. In the focused ion beam processing, the main challenging task is to study secondary effects either in terms of experiment or in terms of modeling.
Also, physics governing energy beam interaction with materials is very different for each application. We can use a very similar approach to mathematical modeling.
In STIP project, I'm studying the laser beam material interaction. In particular, I'm involved to understand how the laser beam characteristics can change the final footprint.
Technically, the processes could be described by PD equations. Inside those equations, there are unknown parameters which cannot be obtained directly from the experiment. I use tricky mathematical way to retrieve those parameters from available experiments. Namely, I am using PD constraint optimization.
I'm a materials scientist and I work on materials characterization, particularly investigating changes in microstructure before and after laser ablation.
The most challenging part of my job is to try to solve problems that haven't been solved before, try to focus on something, try to gather some ideas, doing something new every day.
One of the more challenging aspects of the STEEP project is its interdisciplinary nature, which means that we have to be willing and prepared to learn about topics that aren't necessarily associated with our research background.
It's quite challenging to collaborate with other partners because it's not always easy to collaborate with them remotely. It's better if we are there with them, but that's also not possible amidst your busy schedule of doing a PhD.
For each ESR, there are 3 main goals. First, to finish the PhD within the time limit of the project, and the second one, to collaborate other STEEP partners, and the third one, to work for the project as well. So, the main challenging task in the STEEP project is the proper management, means to manage the things in the way that they can achieve success in all 3 goals.
I chose to work on the Marie Curie project because it offers researchers the chance to collaborate between several top-level European institutions, and it's adequately funded and had an excellent location.
One of the things that I really like about the STEEP project is the possibility to have a lot of interaction with different people from different countries, and this is very valuable for me because I learn to know another culture.
Also, you constantly communicate with another PhD students and go for secondments, and as that you get to know, for example, for STEEP project, 5 foreign countries.
Marie Curie project is a very demanding one. In particular, asks you a lot of resources. But at the same time, this project permits me to do what I want to really do in my research. It permits me to explore the field that I like more.
It also gives us the opportunity to do additional skills training. For instance, we did a workshop in leadership and management, and this is very useful in the implementation of a STEEP project and also for our future career.
You have funding to do the most interesting things that you want to do. You get in touch with other people who are in your same position, other early stage researchers. You can collaborate with them. You meet them regularly for work. You have project meetings.
The main advantage for me of STEEP project is possibility to collaborate between different universities.
You also are in touch with industrial partners, which is very interesting for the work.
The best thing about my job are the challenges. I get constantly intellectually challenged, and I get a lot of resources to make my brain work and finish a task and resolve problems.
Au revoir.
Hasta luego.
До побачення.
Ciao, ci vediamo.
Nandri.
Au revoir.
Всего доброго.
Па-па!
Namaste.
Bye bye.